So in this question, we're given an expression for t, showing that t is equal to the square root of w over d cubed. And just to make this a little bit clearer, we can put brackets around the w over d cubed to show that we're finding the square root of the whole thing here. So we're finding the square root of everything that's inside the brackets. We're given the values for w and d. So w is equal to 5.6 times 10 to the minus 5, and d is equal to 1.4 times 10 to the minus 4. And we're asked to use this information to work out the value of t, given our answer in standard form, and correct to 3 significant figures. So if we want to give our answer in standard form, we already have these values here for w and d. These are in standard form. So standard form is when you've got a number here before the multiply sign, which is greater than or equal to 1 and less than 10. So it can't be 10, it has to be between 1 and 10, less than 10. So what we can do is take the expression for t and substitute in the values that we have for w and d. So t is equal to the square root of w, which is 5.6 times 10 to the minus 5, divided by d cubed, which is 1.4 times 10 to the minus 4, all cubed, and all of that is going to be under the square root sign. We need to make sure that we cube the whole of this value here. So by putting that in brackets, that makes sure that we do cube the whole value. So you can then substitute what we've written out here into the calculator, and that will come out with a value of 4,517.5395, etc. So it's really important to make sure you type this into your calculator correctly, having all of this expression underneath the square root sign and making sure you cube the whole of this value here. So that comes out with this value, and we need this correct to 3 significant figures and in standard form. So firstly, we can convert it into 3 significant figures, so we're going to have to do some rounding. So this would be the first, the second and the third. So we're here with the 1, and to the right of this we have a 7, and the 7 is greater than or equal to 5, so that means we're going to round this 1 up to a 2. So that leaves us with 4,520 to 3 significant figures. Now we can put this into standard form. So again, we need a number between 1 and 10 basically. So we can take it down to 4.52, which is between 1 and 10, times 10 to the power of some value. And if we look here, if we were to pop the decimal point in here, we'd have to move it 1, 2, 3 places to the right to raise it to raise the value of 4.52 to 4,520. So we've had to move the decimal point 3 places, so we've had to multiply it by 10 to the power of 3. So 4.52 times 10 to the power of 3 is going to be the correct answer for t to 3 significant figures and in standard form. So you get the first mark here for this correct unrounded value of t. Alternatively, you could get the first mark for finding the value of w divided by d cubed. However, I've kind of done it all in one step and taken the square root at the same time, just to make sure we don't get any kind of rounding errors or anything while we're calculating the value. And then the second mark is for the correct final answer of 4.52 times 10 to the 3. So now in this part of the question, we're told that w is increased by 10%, and that d is increased by 5%. We're told that Lottie says the value of t will increase because both w and d are increased. Lottie is wrong, and we're asked to explain why. So here we're working with these new values of w and d. So we're looking at new values, and we want to use these new values to see whether the value of t that these values produce is greater than or less than the previous value of t that we calculated. So one way we can do this is by looking at the scale factors by which w and d are multiplied in order to get the new values of w and d. So if w is increased by 10%, that's the same as multiplying the original value of w by 1.1, so it's a scale factor of 1.1, gives us the new value of W. Similarly, for D, D is increased by 5%, that's the same as multiplying by a scale factor of 1.05. So this 0.05 gives us the 5% increase, the 5%, and then the 1 shows that we're taking that from the original value. So we're taking all of the original value and adding on 5% of it. So we're told that Lottie says the value of T will increase, so we need to see if this is actually the case. So we can do this by using the scale factors that we've calculated here. And instead of maybe going about the question in a bit of a longer way, we can simply substitute in the scale factors for W and D to get the scale factor by which T is multiplied to find the new value of T. So we can take the expression that we had before and take the square root of W, or the scale factor by which W is multiplied, so 1.1, and divide that by the scale factor by which D is multiplied, which is 1.05, but this has to be cubed because we have the D cubed here. And that gives us an answer of 0.974, etc. And we can now see that T is going to be multiplied by this scale factor of 0.974, 0.97 to get the new value of T. Now, noticing here, 0.97 is less than 1, so if we multiply a value by a value which is less than 1, it's actually going to, the new value produced is going to be less than the original one. So the new value of T is going to be less than the original because the scale factor is less than 1. This contradicts this statement here, that T will increase, because in fact it will decrease. So to put that into words, if we say that the value of the scale factor, which we've calculated for T, is less than 1 in this instance, so there must be a decrease in T, as multiplying any value by a value less than 1, this value of 0.97, is going to give us a decrease in the original value. Alternatively, we could have gone about this by taking the original value for W and D and multiplying them by their scale factors and then substituting them in to find the actual value of T once these changes, these increases in W and D have been made. And you'd then get a value for T of 4.4 times 10 to the 3, which you can see is less than the original value that was calculated for T, which was 4.52 times 10 to the 3. So you can see that T is decreased. So the marks here, the first one would be for calculating this value of the scale factor, and then the second mark is just for justifying that with a few words at the end.